is Socrates Xanthus. I'm the adjunct professor at UCF for commercial real estate finance. So today I want to talk about an exercise. There are three questions in this exercise. The first one is a simple present value question. And this exercise you're giving, or this problem, you're giving three things: the number of payments. It's asking you for the present value of an annuity. If you're receiving $80,000 a year for 5 years, you're receiving a lump sum payment at the end of 5 years for $1.4 million at a rate of 11%. This is a fairly easy time value of money exercise that you're going to find in finance. So let's go ahead and get started. What you want to do is set up your spreadsheet with the present value, or this table you see here, where payments will be lined up in this row, in the years, the lump sum payment, and your total. And then you're going to have to put another row for where you're going to want your answers to be calculated. To begin, I'm going to go ahead and, since the problem is telling me that I'm going to get $80,000 a year, and it is going to be consistent over the next 5 years, I'm going to say that year one, it's going to equal to the 80,000. But what I'm going to do is I'm going to anchor this, because it's going to be the same amount of money that I'm going to get every year thereafter. Once I anchor that, I can simply drag the years 2 through 5 to get $80,000 a year. And it's also telling me that I'm getting a lump sum payment of $1.4 million at 5 years. So I'm going to go to year 5. I'm going to say year 5 is equal to my lump sum payment. So I have that. I don't have to anchor that, since it's only going to happen once. And the total row is going to allow me to total how much money I'm getting every year. And that's very critical when you're calculating NPV, since the values have to be in the same row. I'm going to do a simple formula here: equals sum of whatever happened in year one, including payment and lump sum. But obviously, I only had payments, no lump sum in year one. Let's go back. Equal 80 plus year, so 80,000. I'm going to drag that across so I can get the same formulas for year 5. You can see it's totaling the payment plus the lump sum amount. And to calculate the net present value, I'm going to just use the net present value formula, which is NPV, tab, open parens. And Excel does a very, very good job at telling you what you need to put in these functions that are already built in Excel. It's telling you to get the rate. The rate happens to be 11%. And since it's an annual rate, you don't need to divide by 12, and you're going to hit comma, and you're going to begin with the first year of value and drag it across to year 5 and close paren. And your answer is a net present value of receiving $80,000 a year for 5 years with a lump sum payment of $1.4 million equals 1.126 of $1,126,000 roughly. So that's the answer for question number 1. Question number 2 and 3 are a little bit more complicated, because there's a few things happening here. This is a remaining balance formula. I've entered the information that's given to us for question number 2. This is a remaining balance for a loan where you borrowed $2 million at an interest rate of 4.15% for 20 years. The question is asking you, after you make 4 payments, what will be your remaining balance? So you need to do a few things here to get to that answer. Don't forget, it's asking you for the remaining balance. So I've populated the information that's given to us, and I have it in gray. This is information that's given to you in your problem. So the first step is going to be to calculate the payment per month. And Excel has a function for payment. It's PMT, so equal PMT. As I mentioned before, Excel does a very good job at telling you what to do for these preset functions. It's asking you for the rate. Since it's a monthly payment, you're gonna it's asking you for the rate. Divide that by 12, and you're gonna hit comma, and the next one is gonna ask you for the number of payments. it is 20 years, but since it is a monthly calculation, you're going to multiply that by 12, and it's asking you for the present value, meaning how much money are you borrowing, how much is the loan amount. You're going to click on the loan amount, and you're going to hit comma, and it's asking you for the future value. Since it is a fully amortized loan, at the end of 20 years, you will have owed zero. You put zero for the future value and close paren, and you have your answer, which is $12,278 a month. Now, to calculate for that for the annual payment, that's fairly easy. It's going to equal the monthly payment times 12. Times 12. And your annual payment or debt service is going to be $147,339 for your annual payment. The next step in this problem, again, the question that it's asking you is, what is the remaining balance after 4 payments? Not 4 years, but 4 payments. So there are 2 ways to calculate remaining balance. The first one is the PV function. We're going to do that one first. PV function is the present value function. So Excel has that. And when you're calculating present value, since it is a loan, you're going to have it be negative. So it's negative PV. And again, it has the formula in here for you to calculate present value. It's going to be the rate, and you're going to divide that by 12. And it's asking you for the number of payments. The number of payments is 20 years times 12. Times 12. But what times 12. But what I'm going to do here is to make this simpler, I'm going to do number of payments times 12 minus the number of months after how many payments, which is the 4 payments in this case. And you want to hit comma, and the future value is going to be 0. Once you close paren, you should have number of payments and payment. Oh, I forgot. I apologize. Number of payments. We forgot the payment piece. Very important that we do that. The payment piece that we calculate, and then comma 0. So you should have $1.9 million after your first 4 payments. That's how much money you would have remaining. Okay, so let's go over that again using the PV function. It is negative PV, the rate divided by 12, the number of payments, which is 20 times 12 for the number of payments in months, minus the remaining, minus how many payments after for the remaining balance, which happens to be in this case 4. And it's asking you for the payment, which is the monthly payment that you've calculated, and then the future value will be 0 since this is a fully amortized loan. So that is using the PV function. To use the cumprint function, you're going to start with equal negative the current loan amount minus cumulative print. This function is going to be used heavily and often in this course, so make sure you know how to use the cumprint formula or function. So we're saying here the cumprint in Excel is telling you to find the rate, and it's going to be divided by 12, the number of payments, which is 20 years times 12, the present value, which happens to be the loan amount, and it's asking you what is the start period. Obviously, the start period would be 1, and the end period will be the 4 months. After 4 months, that will be the end period, and you will put in 0 for your type, and you 0, and you close paren. You should have the same answer as you got for the PV function. If your answers are not matching, one or both of the functions are incorrect. In this case, we got $1,978,000 and $442. $1,978,442 for both the PV function and cum print function. Just to recap what we're doing here, it's asking us how many payments, after four payments, how much do you owe if you borrow $2 million? And if you borrow if you wanted to change the number of payments after one payment, you would owe 1.9 million. If you after 12 payments, which is 1 year, you would owe this amount, and so forth and so on. So, for example, after 20 years, which would be 20 times 12, or 200 and 120, I believe. 20 times 12. 240, I'm sorry. After 240 payments, you would have zero. So if you, after 240 payments, if you put that in here, if you don't have zero, then your formulas are incorrect. So let's go back to the one. So that would be after one payment or after four payments, this is how much you would owe. Let's do the same exercise, but using the remaining balance for years. So we're going to do the same problem here. It's asking you if you borrow $2.5 million at a rate of 4.75. This is not a fully amortized loan because your amortization period is 20 years and your term is 7 years. This is a balloon payment, not a fully amortized loan, meaning after 7 years, you'd have to either refinance or sell the property. But the question is, how much will your balloon payment be after 7 years? It is slightly different than the one above since it's using years as opposed to months, and it is not a fully amortized loan. But it starts off the same way. The monthly payment would be, using the payment function in Excel, rate divided by 12, and you have number of payments, which is times 12, and your present value is the loan amount, and your future value should be zero because you're calculating the payment using a 20-year amortization. Your monthly payment, if you borrowed this amount of money, would be $16,156. Obviously, your annual payment would be the monthly payment times 12. Your annual payment will be $193,877, and we don't like to use the cents, so we'll remove those. And then we're going to use the same PV function or a very similar PV function and a similar cum print function to calculate the remaining balance. So calculate the PV using the PV function is going to be equal negative PV, and it's asking us for the rate, which is again divided by 12. Number of payments. Number of payments in this case is obviously 20 years times 20 year times, 20 year minus the term, but we're going to put a bracket around it, and we're going to then multiply that by 12, since the monthly payment is calculated using the monthly payment, comma, the monthly payment, which we have there here, and it's asking us for the future value, which should be zero if it's fully amortized. Your remaining balance should be 1.8 million and some change. And we're going to calculate the same remaining balance using the cum print function. It's going to be equal to the original loan amount minus cum print. And we're going to use the Excel hence here. Rate divided by 12. We're going to use number of payments. It's this times 12. We're going to put the present value is the loan amount. The start period is going to be 1, and the end period will be 7, the term that you have here, times 12, because we're going to do this in years, and we're going to 0 to close out our function. You should have the same answer, $1.8 million and some change. So this answers your question. There are 3 questions answered today for this video: how to calculate the net present value of an annuity, how to calculate the remaining balance from a fully amortized loan, and how to calculate the remaining balance for a partially amortized loan. Hopefully this was helpful to you. Please be sure to subscribe to the channel so that when I upload new videos, you'll be automatically notified. Have a good weekend.